Here is a bird's eye view of two hallways, each with a different width, that meet at a right angle. Suppose you have a large pane of glass that you need to move around the corner, from one hallway to the other. What's the longest it could possibly be so that it could still move around the corner without getting stuck? Let's start by calling the length of the glass L. This is an optimization problem. Instead of looking for the longest object that could go around the corner, let's find the shortest object that could not. To do that, we first need to define the length as a function of some other variable. When it's touching both outer walls and the inside corner of the hallway, it will form two similar right triangles. So let's call the corresponding angles of these two triangles theta. We can separate L into two smaller segments, L1 and L2. These are the hypotenuses of the two triangles. Focusing on the lower triangle, if we take the cosine of theta, which is adjacent over hypotenuse, we get A over L1. For the upper triangle, if we take the sine of theta, or opposite over hypotenuse, we get B over L2. Now let's solve these two equations for L1 and L2. Cosine is the reciprocal of secant, and sine is the reciprocal of cosecant. Remember that L1 and L2 are two line segments of the original line L, so we can add them back together to get a function for L in terms of theta. This is the function we want to optimize. To do that, we first need to take its derivative. So A secant becomes A secant tangent, and B cosecant becomes negative B cosecant cotangent. Now that we have the derivative, we can set it equal to 0 and then solve for theta. One thing I often tell students when it comes to simplifying trig expressions is that if you're ever stuck or unsure what to do next, just write everything in terms of sine and cosine. That usually clears things up and makes the whole thing easier to solve. So now we can simplify. We can cross multiply to get A sine cubed equals B cosine cubed. Divide both sides by A, then divide both sides by cosine cubed. Sine cubed over cosine cubed is the same as tangent cubed. Take the cubed root of both sides, and finally, take the arctangent of both sides. This is the angle that will yield the optimal length we are looking for. If we want to plug it into the original function, the easiest way to do that is to first revert it back to tangent theta, and then split the cubed root to the numerator and the denominator. Now, let's construct a right triangle with angle theta. Tangent is the opposite side over the adjacent side. We can use the Pythagorean theorem to find the hypotenuse. When plugging in the values for A and B, it'll make things easier to rewrite the radicals as rational exponents instead. Take the square root to solve for C, and we now have an expression for the hypotenuse. This will allow us to evaluate any trig function we need. Secant is the reciprocal of cosine, or hypotenuse over adjacent, which gives us this. And cosecant is the reciprocal of sine, or hypotenuse over opposite, which gives us this. Now we just need to clean this up. A over A to the 1/3 is A to the 2/3. And B over B to the 1/3 is B to the 2/3. Each of these two expressions contains the same exact radical. Therefore, we can factor it out. And let's go ahead and rewrite it with a rational exponent of 1/2. This is a product of two expressions that have the same base, so we can combine them by adding their exponents to get a power of 3/2. So now we can convert all these rational exponents back to radicals, and we finally have our formula. This formula will tell us the longest object with negligible thickness that will fit around the corner of two different sized hallways. I hope you enjoyed this video and that you learned something new. If so, please take a second to like and subscribe. Thank you all for watching and have a pleasant day.